Performance testing. This presentation is intended to give an overview about what is performance testing. We will be briefly looking into different types of testing and other jargons related with the performance testing. We also will be looking at an example how we will be doing, how a software performance engineer will be performing the software testing. Before going into the presentation, let's look into the preface. This presentation is intended for someone with some knowledge in software testing industry. Any programming or coding knowledge is not required to understand these concepts. This is a conceptual level presentation. We will be trying to understand what is performance testing and what's the relevance of it. The goals and types of testing will be another topic which we will be discussing. After that, we will be looking at couple of scenarios for a system under test and trying to understand what are the points we'll be analyzing after the test. Performance testing is a kind of testing. In QA, there are different types of testing. One type of testing is performance testing. We know that we divide QA into performance testing, functional testing and non-functional testing. Performance testing is a non-functional kind of testing. In performance testing, as the name suggests, what we do is we analyze the software, we evaluate the system when we apply a load. What we are trying to look is like how the application is performing. We do it by analyzing different matrices. We might be looking into scalability, reliability, speed, and resource usage. These are some matrices which are relevant. There are other matrices which might help in this journey. So let's assume we have a software to book flights. We can clearly assume that if we have a software for booking flight, there might be multiple people accessing the same system at same point of time. So if that system cannot handle the load, that means if the system cannot allow multiple people to enter into the system, we will lose the potential customer. This might be cause a loss for the software. This might cause a loss for the business. This is why performance testing is important. Normally we do the performance analysis once the functionality is bug free. That means we have a software and we are going to do a performance test on a functionality. So we assume that the functionality is working properly. Once it is working properly, we do the performance, we induce load into that functionality, and we see this functionality is working properly under load as well, under the intended load. Sometimes a small business might be acquired by another big business, and from there we will be having a bigger client base. So the bigger client base might use the software, might use the simultaneous increase in simultaneous users for the softwares or concurrent use of the softwares. This is another point, another business angle in which we will be doing performance testing. Software testing is generally classified into functional and non-functional testing. In the functional testing, as we all know, we will be focusing on the functionality. We will be checking if the functionality of the application is working properly or not. We will be providing some inputs and we will be validating if the required actions are performed or not. Similar to functional testing, we have non-functional testing as well. Some typical examples will be usability testing or security testing. Our prime focus, performance testing, is also classified under non-functional testing. One of the prime criteria for us to start performance testing is that we know the system works. That means we we will be getting a system that will be already tested by QA members. If the functionality is not working, the results which we get from the performance testing will not be accurate. So one of the entry criteria for the performance testing is that functional testing should be completed and it should be certified by the stakeholders. Now the point which we will be validating will be like if the system is working, if the functionalities are working properly at specific conditions. There might be a acceptance criteria defined such as X number of users concurrently applying on the system, performing actions on the system. Depending on the application, the action which we are performing on the system might vary. For example, if we are working with the SNTP protocol, the email, sending an email, receiving an emails might be the actions which we are performing on the system. Similar to that, sending request might be another point which we'll be doing on some other kind of protocol when we are working with some other kind of protocols. Based on the purpose of goals, we have classified performance testing into multiple categories. Couple of the names you have heard might be load testing, stress testing, spike testing, etc. Let us look into that little more deeply. What is load testing? Load testing is a type of performance testing where the expected load, the load we are generating is less than or equal to number of expected usage for that application. Let's assume there is an application which will support 1000 concurrent users. When a performance engineer create a load less than or equal to that expected number of users, that expected number of concurrent users, it's called load testing. Similar to that, we have spike testing. In the spike testing, as you know, we spike the load. We increase the load very fast for a short period of time. One of the scenarios which I remember where this is relevant is from Indian Railways. Indian Railways has an e-commerce application which allow us to book the tickets. One of the feature of that web application is a feature called Tatkal tickets. Tatkal tickets are some kind of tickets, is a kind of tickets where you can book the ticket just few hours before starting the train. There will be a small amount of tickets that will be reserved for this time period. So I remember trying to access IRCTC Tatkal ticket part feature before Christmas holidays. When I was planning for Christmas holidays, I may forget to book it early, and right before the day, I would be trying to get a Tatkal ticket. So the problem is like there will be huge number of people who is trying to access the same feature at the same point of time. It will be not the normal case. It will be a special case when we are considering the holiday season. Similar to that, if you are looking at the Black Friday sales for an e-commerce portal, the sales will be much higher than the general load. These times are some examples for the real-time spikes in customer usage. SOC testing is also known as endurance testing. In this SOC testing or endurance testing, what we are trying to do will be like holding the system, generating the load, and holding the load for a prolonged period of time. It will help us to understand it will help us to understand a couple of features related with system. Maybe like what is the memory usage, or will the system will be able to withstand a load for a prolonged period of time. If there is any other system resources that are being overly used, or is there any memory leakage or some points like that. Similar to that, to know the scalability also, we might be doing the performance testing. Stress testing is something like we are going beyond the expected number of users. So if a system supports 100 users and if you are trying to stress the system by using more than 100 users, then it is generally known as stress testing. In the previous slide, we have seen different type of testing. This is a continuation from the previous slide. So let us focus on the graph which is shown here. On the x-axis, we can see timeline, and the y-axis we can see number of users. So there is a graph plotted for the traffic which is in correspondence with the timeline. Let us look at the blue line, which is related with the load test. In the load test, we gradually increase number of users to a certain point, to an expected number of users load, and we perform it for some time, and we end the test. In the stress test, we are increasing the load continuously until we reach a point where our system will break. You can see this in the graph as red lines. The green line represent the spike test. If you look at that green line, you can see number of users are increased spontaneously, and then it is decreased. We will be repeating this for a while. This is called spike test. I would like to take your attention to a couple of points which we should focus on before starting the performance testing. One of the main point which you should always focus is what is acceptance criteria. We will have to speak with the stakeholders for this. There might be multiple stakeholders for a team. We have to interact with each of them and come to an agreement what they are looking at. For example, it might be like 100, our system should be able to support 100 concurrent users for X amount of time. Stakeholders may not be able to provide acceptance criteria directly. We might have to formulate it from the discussions which we initiate. Another point is like we are going to give the reports to the stakeholders. We should provide the reports what makes sense for them. For example, if it is a business team, providing details with number of requests and the details of errors which we got may not make that much sense. We might have to process it and provide the results in a way they can process. Let us look at the key parameters that a performance tester will be looking at while doing the testing. A couple of them is displayed on the screen now. For example, we will be looking at the response time when we are generating a load. Say, for example, we are generating a load for X users, X concurrent users, and the system might show a drop in response time compared with the previous performance test results. Similar to that, system may not be available when we are generating a load that more load than system can handle. So these are the couple of values which probably we will be getting it from the load test in the report in the load testing tool. Resource usage and error handling, we will have to look at the server side. It might be available in the server logs. Resource usage, we might have to use a monitoring tool. We might be using a different monitoring tool for specific applications. We might have to look into that tool and fetch the details of the resource for the resource usage. So how do we start performance testing? We don't start the performance testing directly, like increasing or generating a load on a specific request or on a service. We have to figure out the purpose of the testing. Maybe there might be multiple reasons why we have to do a performance testing. Maybe our client base is getting increased due to a merger or an acquisition. Or maybe we are getting a complaint from a current group of people who are using the system that our system is slow, or maybe there is a study which says our application should load within so and so seconds, otherwise people will not be that much interested to look into that. Multiple reasons might be there. Based on this reason, we have to find the load we have to generate. You have to interact with the multiple stakeholders. You have to speak with the business analyst. You have to speak with the other people who are involved and find out the purpose. So once we are able to identify a couple of things, maybe you got an acceptance criteria, then another thing you have to do is like you have to understand the application which you are going to generate the load. You have to find what is the protocols being used, what are the requests we are going to generate the load, and how this system is built. Maybe there is one request that will be related with another request. There might be a correlation between different parts of the different features of the application. So you have to identify the application. You have to identify the workflows. I would suggest like you have to identify end-to-end workflows which you are going to do. There might be separate parts of uh, application. For example, there is a there is an application in an application there might be a place where you keep an order, and there might be another part of the application which sends an email for that order, which may not be interdependent. I mean, they are dependent on each other, but you can test it separately, performance test it separately. So you have to identify such points, and you have to come up with a strategy how you are going to run the workflows. So once you have the workflow, once you have the clarity of workflow, the other thing normally I do is like if it is going to be a API request, I try to call that API from Postman and see how it works. So my point is like it do not increase the complexity of doing it. So if I am able to do it manually by using a tool, I understand. I just translate this into my performance testing tool. So if there is any limitations for the application, you have to identify those things, and there might be sometimes you have to do a POC and see. When you're doing a POC, you have to prepare for the right sample set. You have to. It's not like you're doing everything from a group. You are getting a sample and you're making sure that that sample works properly, and you are analyzing the results. One of the most important part is to analyze the results. So these are the steps which normally people follows. Let us look into that more deeply in coming slides. In this current slide, we are going to look at the couple of workflows from a e-commerce portal. All of you might have seen Amazon.com or some other portal like that, which sells some products. So, couple of things that we do in that e-commerce portal is like we try to search for a product. We if we like it, we add it into a cart and we buy the product. There are little more complication than that when you're looking uh, at at the e-commerce portal in a technical perspective. Sometimes you might add something and you'll feel like you need to check it in or some other website, or you might think like, oh, okay, I don't need it anymore. So there is a possibility that we can abandon a cart. Another action is like we needed 10 items and we got 10 items. We added those to the cart and we will try to make a payment. And payment will be go through, and and then the item will be shipped. Sometimes the payment may not go through, and the payment might get declined. That's another case. Or even sometimes we will we will we will say like, okay, this product got a discount in some other, maybe got a 50% discount in some other website, so I will buy it from there. So we'll abandon abandon the cart there, and we will go to a different place. That can also happen. So once we are making the payment, the item will be shipped to your home or the address which you are provided, and we got a happy customer. Sometimes we will get not that happy customer who will decide to send our product back, and we have to refund the amount. So these are the couple of actions which are happening in an e-commerce portal. So when you are going to do a performance testing in such an e-commerce portal, you have to look at the acceptance criteria. One of the business case might be 100 users will be browsing at 20 different products at the same time, and out of the 100 different users, 50 users will do a checkout successfully, and 10 percentage of the people who got the product, that means here 5 people, because 50 people, here 50 people had done the checkout part, and 10 percentage returned the product, which means 5 users returned the product. So these are the couple of scenarios. These are the couple of business cases which will be happening. Scenario that need to be load tested. Here you have to understand that certain scenarios will have a much higher load at a point of time. At the same point of time, certain scenarios may not have that much of load. So when all of these things done together will give you the accurate results. There might be when I say the when I say Amazon, you know that Amazon directly may not be directly shipping the product. They might be placing the order into a different system for a different logistic provider, the people who sends the product to your home. They might be designed a different system, and that system may not be that efficient as our e-commerce portal. So that is a constraint that will limit our performance as well. So without getting a confirmation from the shipping system, we will not go to the next page in the application. So it is a limitation that we are getting it from the interacting system. Or there might be another email that need to be triggered, and after that that will be done by a different system, and after that only we will process with our system, current status in our system. So these kind of things will be another points which need to be considered while doing a performance testing. So CRM, for example, if you have got a customer relationship management system, a different one from our application, then what happens is like there might be some read and write, maybe read or write. Uh, there might be some write happening into their database, or the information need to be shared with the CRM systems. So that kind of things, if getting constrained by like constrained, and if we are waiting for the input from those systems, that might also impact our system. I'm just trying to explain a couple of points that might help you to think in the future, when we are going into the future slides. In the previous slide, we have looked into different scenarios that will be used. In this slide, we will be looking into different steps that that will have an impact. So one of the first steps which we have to do is the identification of scenarios. from the previous application we have discussed, we can take checkout as one scenario, or we can use browsing as another scenario. There are other scenarios which we have already discussed, such as shipping. So identification of all these scenarios prior to beginning of the testing is one of the important steps which we have to do. From there, we have to go into a phase where we have to figure out the correlation between each scenarios. For example, shipping can be done only if the prior step, that is the checkout, being successful. Here you have to remember that some parameters or some values from the checkout might be used in the shipping scenario. These need to be passed from one request to another one. The easiest way to organize this is to finding the starting and ending point. So once you decide the correlation and the scenarios and the correlation, you have to find from which request we go to what request, and where we can say like there is an ending point. Another factor which influence and we have to look prior to design is what all are the inputs we will be providing over the test data. Collecting the right samples. Um, in the case of e-commerce portal, which we have looked into, we have to see there might be different groupings for the each inputs. So which all inputs make sense, that should be figured out, and it should be provided into the test during this phase. We have to understand during this phase. From here, if we have done these 4 steps properly, the life becomes very easy for the next steps. Next step will be load generation. For that, normally we will be depending on some kind of tools such as Demeter or Gatling. So these kind of tools will generate a list of virtual users that will generate the load to the system which we are testing, that is system under test. Once the load is generated, we have to monitor from the reports which we are getting on the testing application, as well as other monitoring tool which monitors our application. One of the key other aspect which we have to look at is environment. Environment need to be equivalent to the production environment. Environment need to be similar to what we are going to get on the production. But the challenging condition here exists is due to cost. It may not be practical to keep switch on or to hold an environment equivalent to the capacity of production for testing. So this might come as a challenge. Another point which we should keep in mind is we should never do a production testing, I mean performance testing on a production environment. On the right side, you can see a couple of measurements which we will be taking from the after completing the performance testing. So one is the response time. Another kind of report we will be looking will be resource usage. There will be also We also should look at the failure rate or the error percentage. We will have to discard the test run if the failure ratio is higher than the expected one. Throughput is another report. Now let's see the load related things which we have to bear in mind when we design a case. We have already discussed that we will be using some kind of tool, and we'll be generating, and virtual users will be generating the load. So normally we have to start testing less than the infrastructure capacity of the application. Here we have to here normally what we do is like we start load on a lower percentage, and then gradually increase the load. We call it as ramping up the users. After on a specific intervals is one of the ways we do the testing. So there are other cases where we spike the user capacity as well. So load breakdown is like we have to look at the scenarios and see which what are the scenarios and how the load will be impacted on the system. And let's look at the reporting part. In the reporting, we are not speaking about the reports which we are going to get after the testing. This reporting is something like we will be logging certain things. For example, when you generate an application load, the application will be logging certain things on the log files. So all these things which we can analyze if you see a error and try to figure out what is happening. Another point is like we have to log the test data which is being used. It will probably automatically done by the application system under test on some log files. Another place which where you can look is like on the tool which you are going to generate the load. From there, you can see the request which probably you will be able to see you will see the request which will be sent to the server. On this slide, we are specifically going into the tools which can be used for testing, and also it gives some idea about the couple of tools which will be monitoring the system under test. Also, the log management tools which might be used by system under test. So, as a performance tester, we will be looking at the load generation tools. We have to do a POC. Suppose if you're going to start a new project and you believe that uh, before confirming that if that tool can be used, we have to analyze the tools and then we have to figure out which tools will be apt for this. Here I have mentioned a couple of tools: JMeter, Gatling, K6, and other one. There are other tools also available in market. Some of the tools might be paid tools, for example, LoadGen, Load Runner. Here, first thing you have to understand is the protocol which is being used should be supported by our tools. If you are looking at the Gatling, it has got open source version as well as enterprise version. Some of the protocols will be exclusive for enterprise version. JMeter and JMeter also has got similar limitations. Uh, we there are only a limited set of, I mean that limit is high though. There will be a certain set of protocols that will be supported by JMeter. I also would like to mention that certain companies use their own customized tools. I know one of the such company which does that. I just wanted to mention it. Application performance and monitoring tools are normally set up by the infrastructure team, which will be already there, or it can be part of our testing performance team as well. In that case, performance team might be a performance engineering team which has got a broader set of skills. Normally, I would say performance tester will be limited to the exposure in load generation tools and will be more often looking into these application performance monitoring tools to understand and get the results. Setting up of those tools may not be the part of performance testing in the normal scenarios. Log management tools also will be set up by infrastructure or the other performance engineering team members. Performance testers might have a limited role in setting up of these tools. Splunk is one of the tools which I have used. So where you have to, one of the advantages is like you can search and you can um, get what is happening. When there is an error, what you have to do is like you have to go into the log management tools and then to figure out what went wrong when the testing was started. There will be a there will be a lot of a lot of events that happened, and you will be able to see, and you will be able to filter it out. That will be kind of very helpful when something goes wrong. So coming back to the application performance and monitoring tools, after completing a load generation, we'll be looking at the application performance and monitoring tools to see how the system was impacted, how the resources was consumed, resource utilization or CPU utilization, memory utilization, things like that will be looked based on these application monitoring tools which we are using. Based on our results from the performance testing, there are multiple activities that can be optimized and helped. One such thing is capacity planning. From the reports of performance testing, we will be understanding the resource utilization as well as the our application's behavior under a specific load. So we have to discuss with the different stakeholders and figure out what is the number of concurrent uses that need to be that will be impacting that will be accessing our production. So based on that, we can share insights with infrastructure teams, and they will be able to optimize optimize the infra needs. There will be special conditions. For example, for an e-commerce web portal, Black Fridays has got a significant impact. There will be much more number of people will be accessing our application during that time period. Similar to that, if you are running an e-commerce portal for donations for a humanitarian organization such as Red Cross or some other NGOs, and the number of users accessing these systems will be much higher during a hurricane or during a wildfire, during an unfortunate events. So these kind of things can be projected, and we can be planned so that everyone will be able to access our application when they are trying to when they are when they are trying to access. So the scalability also can be planned and projected based on the reports which we provide. Another important thing is like the benchmark comparison. For example, e-commerce portal normal e-commerce portal response will be so and so seconds or milliseconds, and if our application is performing much poorer than the benchmark, then that will be that will be a problem. Identifying some areas which has got extreme delays, such as DB read or reading from the cache is taking too much of time because of certain reasons which we are unaware of. Those kind of things can be uncovered by using our performance testing results. Certain teams, certain high performance applications such as those we can see in the stock market, even unless each versions of applications they release, the performance of the prior version and the current version along with the benchmarks will be compared, and that will be the important that will be the part of a regression as well. As we discussed previously in the capacity planning, we can also bring in cost optimization. When we are not when we can adjust our infra based on the projected loads and infra needs. We can project it based on the results which we are providing for the as the part of the performance testing. I wanted to show a sample report from a performance testing tool. This sample report is taken from JMeter. Here you can see the thread groups and number of samples and other values mostly related with the time. Samples denote number of requests which you have sent, and the average time taken is also shown there. Here another value which you have to look at is throughput. Throughput is like number of responses which we got per minute here, and the error percentage also should be validated. If the error percentage is more, we have to discard more than the accepted percentage. We have to discard this test run and we have to do it again after resolving the issues. We have discussed previously that we will be getting reports from the application which we are using, performance testing application which we are using, and from the application monitoring tools. This is a sample report from the CloudWatch, and here you can see memory utilizations and CPU utilization, network, number of nodes, etc. So these, if one of these CPU utilization goes beyond X percentage, then you can certainly say that we have to provide more infra capacity. Let's take a quick recap. In the beginning, we have seen like what are the importance of performance testing and a couple of jargons that will help you to understand the scenarios. We also saw a couple of graphs that will help us to understand different types of performance testings. From there, we try to see a e-commerce portal and different scenarios on that. Based on that, we try to explain and discuss about how a performance testing should be done. We also looked into a couple of report from both application monitoring matrices as well as from load generating tool. So if you are clear on those parts, and if you have once you are going to do the performance testing, there are a couple of steps that will help you to understand. There are certain practices that will make the life much easy. The first point out of this is you have to plan before you do. You have to find out all the necessary information, such as what is the acceptance criteria, and other points such as which protocols are being used, what is the input, what are the input requests, what are the data which need to be shared. The points like that should be identified and listed out. Also, you should identify the entire scenarios that makes relevance for you. Identify which all scenarios should be loaded together and how much of resources, how much of system resources, how much of virtual usage is required for the testing. Another point is like keep your test organized and structured. If you're taking in the case of JMeter, they have got their own plans. You have to create a test plan. Under that, you have to create a thread group, and then you can load the request, load the generate the you can generate the request. Similar to that, if you're using some other tool like Gatling, you have to remember that to segregate different points such as source code as well as the supporting data files and organize them separately. If you have some functions that helps during this process, you have to keep them aside from the away from this. You have to group it and keep it structured. So we also should be keep in mind that these tests which we design should be able to be extended. For example, we might be today we might have the request to generate a load for 10,000 users, but eventually the load might be higher. So we should be planning like how we can increase, how we will be able to extend our testing. We also should give provisions for adding more related scenarios, parameterization. So instead of giving same request again, if you have the provision, if you can do the provision to change inputs for each request, it will be good. Sometimes the data might be loading from an Excel sheet, or you might be able to load it from the CSV sheet. There might be different logics can that might be applied in this parameterization. For example, if you're using Gatling, there are a couple of feed days like circular feed days or linear feed days, etc. Reporting and debugging workflows. Here you have to remember that most of the times we have to do a couple of debugs before we get it right. During the scripting phase, we have to keep in mind that we should have the provision to look into the logs. As we have discussed previously, we should always separate data from the actions. You can keep it aside on a different file, or you can keep it in a separate data files. It should be always removed from source code, so that if we have to change data at some point of time, it will be much easier and less complicated to maintain the scripts. If you have reached so far, and if you think there is some value you got from this presentation, please be generous and give us a thumbs up. Thank you.